Hello there, my name is Arun Gupta and I work in the middleware team at Oracle. Today I'm going to show you a simple collaborative whiteboard. It's a collaborative whiteboard where different shapes can be drawn in multiple colors. The shapes drawn on one browser, for example here, are automatically drawn on all other browsers that are connected to the same endpoint as shown in the URL window over here. For this, we're going to be relying upon WebSocket. This is a WebSocket application. We will be using the JSR 356 implementation that is available in GlassFish 4.0 promoted builds today. So let's take a look at the application first. Now, it says I can choose red color and I want to draw a square and I want to do an instant transfer of the data. So let's see what happens. When I click on this, my developer tools here says I'm sending a text input text data from one browser to the other peer browsers, and it's basically a JSON structure. And on the receiving browser, which is again a peer, the same red square is drawn and it says I received the exact same JSON structure. So that's pretty cool. Let's play around with this. Let's add a couple of more squares. So again, send text is sent, shape, color, and coordinates, a nested JSON structure is sent, same is received over here and rendered accordingly. Now I could change the color, I could draw a different color, I could change the shape and the color, and whatever I draw on one browser gets rendered on the peer browser as well. Now I may say I don't want to transfer the data right away. Let's say I'm going in an offline mode for now. Okay, then I can continue to draw some more images here. Let's say change the color. And now let's say I want to send a snapshot of this data to the browser that is running on the right hand side over here. So I click on the snapshot button here. The exact canvas which is on this browser is now redrawn on this browser as well. And this is achieved by using binary data transfer using WebSocket, and that is again, that data transfer is actually done using the WebSocket implementation layer, which is built into part of GlassFish. Now I also have a third browser running in the background here, which is basically Safari. So this is on the left is Chrome, on the right is Firefox, and this is Safari. Now let's say a third player joins in. Okay, I click on instant mode here. So that means we have started transmitting the data again. So whatever we draw, you can see it shows up on all the browsers. And let's say I stop transmitting the data again, and I start adding some more shapes and figures, and then I say snapshot. This same snapshot is being conveyed to both the browsers, and in that sense they're really true peers. So for example, if I come on this browser here and I say I don't want to transfer the data from this browser to other browsers, I can start making some changes here, and then I can say, oh, now send a snapshot, and there you see, the same snapshot is being sent over to all the peer browsers. Now to understand all of this, how these pieces are fit together, let's take a look at our source code. So this is my NetBeans IDE, this is my source packages here, and these are my pages. So first of all is my index.jsp. Very simple here. I just got radio buttons here for the different colors, for shapes, and what kind of transfer format. Do you want instant transfer or do you want to do a binary transfer? And then of course I'm including a couple of JavaScripts here. So let's take a look at the JavaScripts first. Now WebSocket.js, this is a script that I have created as part of the application. This is the endpoint that we are listening at, and we'll take a look at this in a second. The important part is after the WebSocket connection is initialized, to set the binary type to array buffer. This ensures that anytime a data transfer is done using a binary payload, the type is array buffer. The default is blob, so we need to override that because we are using array buffer for data transfer, and we'll see that in a second as well. Now these are my convenience methods where I just print what is being sent, text and binary. These are my callback listeners for the WebSocket. Like when something is received, you just draw the image, you figure out whether it's a text data or a binary data, and then you invoke the right method. Let's look at our whiteboard.js. Now this is what returns me, when my canvas is ready. Well, first of all, we draw a canvas here, which is HTML5 canvas. Then you get the context, you add a event listener to it. This gives you a convenience method for the current position where you clicked exactly. And this is what defines the image. So in the sense, you go through the input form, figure out which color, which shape, you create a JSON coordinates for all of this, and you draw the image here. And if you say you're doing an instant transfer, then you send the JSON coordinates. It goes from one browser to the other peer browsers. And if it's a binary thing, then from the canvas you have the context already. From the context you get the image data, you convert it into an array buffer, which is a new data type introduced in JavaScript for doing binary data. You convert into an array buffer, provide a view on it for uint8 array, and say send binary. Now send binary is a simple method, as we saw earlier. It's just saying WebSocket.send bytes. Down here we have simple draw image methods here. So you want to draw a circle, square, and things like that. And this is what we have is a draw image binary. So when we get the data back, say on the receiving end, for example, we get the data, on the context we create the image data, and then we do use context.put image data to draw the image back on the canvas. Let's take a look at the Java source code now. Very simple. This is my simple Pojo, saying WebSocket endpoint. This is where I'm listening. I got some encoders and decoders. Now, as you recall, when we were sending text data, the data was coming to us in JSON structure. Now, JSON structure, we could read it in the callback in the message handlers and then play around with them. Or a better way is actually define encoders and decoders, which allow you to transform data from string to JSON structure, using the encoding decoding rules. So if I take a look at figure decoder encoder, here is a decode method which says, okay, now string is coming in, and I'm going to convert this to a simple JSON object. So as simple as that. And once I get the JSON object, then I have my new figure. Figure is my own object, which is a Pojo, and from that I convert what my figure object looks like. Okay. There's a simple will decode method which returns from the encoder decoder. Okay, I am capable of decoding it, and encode is very simple anyway. And that's about it. That's pretty much the application. So as you can see, now if I go back to my whiteboard, I have a simple on open callback handler, on close callback handler. Then here I have a broadcast figure. Now this is where exactly I'm sending the text coordinates of the JSON structure. So all I do is, I say I reiterate over the peers, which are there. If it's not coming from the same client, the idea is you do not broadcast to all the peers in the network. You broadcast. Actually, you do broadcast to all the peers, but you do not broadcast back to yourself. And that's what this if loop is doing effectively. So you just iterate over it and you send the object. And in this case, you're just sending the bytes. So this is a broadcast figure method, and this is a broadcast binary method. Now, as you can see, this is handled by our figure encoder decoder. And this method has a signature. That means this is invoked whenever a binary data is being received. So you can handle your text data, you can binary payload, you can handle your encoder decoder from client to server and vice versa. All of that can be very easily done. And for this, I'm using GlassFish build 64, which has JSR 356 reference implementation already integrated there. So I would encourage you to download GlassFish and try it out and have fun. Thank you.